We take multimodal for granted these days because of the ubiquity of AI assistants, but it's important to appreciate the journey. So Simon Sturmer, who's leading the product engineering team at Ario, here is gonna walk us through what will it take to make voice as our primary interface. Ladies and gentlemen, Simon Sturmer.
Thank you, Ario. I have a short presentation and then a demo for you. And so we came up with the title, AI Conversations Evolved, because we think this is the direction that conversational AI is going in. And when I say conversational AI, specifically what do I mean, right? And so you've all engaged with having a conversation of some kind with an AI, and it probably looks like this, right? You are typing in a question and you get back some sort of an answer, right? This is ChatGPT in the middle. That's Pi on the left, which I think is actually really cool. This is one of the better products, and then we have Claude. But that doesn't feel like having a conversation with a human, right? What we really want is we want to speak in a way that we would speak to a person, and we want to hear back answers in a way that has tone and nuance and captures a little bit more than what reading a Google answer or a ChatGPT answer would be. And so this again is something that is already being done. This is ChatGPT on the left. This is Pi in the middle. This is our product here on the right, which is also a personal assistant that you can speak to. But for this demo, what we want to do is build our own, and we want to do it using React Native. Okay, so at the risk of seeing how well this will work, we're going to fire up our Expo. We've got our Expo running here. We've got our server running here. I'm going to kill it and just restart it just to be, double sure that everything's going to work right. And then we'll fire up our phone here, scan the little QR code as we do with Expo. And I'm going to try to, since you won't be able to see this, I'm going to project this onto there, which adds an additional layer of complexity, but I'm sure nothing will go wrong. This will be great. All right. Okay, so we've now mirrored my phone onto there. Okay, so I'm going to press this, and we're going to start a conversation. If I was to build a mobile app right now, and I want it to work on iOS and on Android, what is the most popular framework that I could do that with without writing any native code? Okay. Let me turn my audio on.
Apps on both iOS and Android.
Sorry, could you repeat that?
React Native is a popular framework for building mobile apps on both iOS and Android.
Okay, so besides React Native, though, what if I want to support BlackBerry?
Flutter is another framework that supports iOS, Android, and BlackBerry.
Okay, you might have made that up, but that's okay. Listen, I have another question. So our friends here have just launched on Product Hunt, and if we wanted to write the most compelling comment on their Product Hunt to get them boosted to #1 for the day, what could we write? And answer me in a British accent. Sometimes I gotta get a hint.
Congratulations on the launch. This product is an absolute game changer. Its innovation sets a new standard in the industry. Highly recommend everyone checking this out. Incredibly intuitive and user-friendly. A must-have tool for professionals.
Okay, I'm just gonna stop you there for a minute. Can you tell me, what are the moons of Jupiter? So there's a reason why I'm choosing this one. We're gonna interrupt it at a certain...
The major moons of Jupiter are Io, Europa, Ganymede, and...
Tell me about that last moon. I want to hear more about that one.
Callisto is the second largest moon of Jupiter.
Close enough.
It is heavily cratered and has an ancient surface. Callisto is composed mainly...
Okay, so what I wanted to show you there was a few things. I wanted to show you that we can use different voices, and we'll talk a little bit about how that's implemented. I wanted to show you that we get the transcript afterwards. And so, what I was shooting for there when I interrupt it is that I was trying to interrupt it at a specific point in the list, and then indicate that the LLM kind of knows where it was cut off and can continue from there, which is quite tricky. And so I'm going to jump back to my slide deck for a moment here, and I'm going to talk a little bit about how we how this is implemented, or at least how you could implement this. And all of this that I just showed you is open source. So I'll show you a link, or more accurately, QR code at the very end where you can have a look at the source code. So I've got a bunch of slides here, and I'm going to try to speed through it because I've got one more demo to show you. So I'm going to kind of gloss over some of this stuff. But as was pointed out in the previous talk, actually I'm really glad that set a lot of this context that we're about to talk about, because that means I can skip through some of this stuff even faster. But this is the state of the art. Like, for better or for worse, the state of the art is you got to convert it to text first, and then you got to send it to an LLM, and then you have to convert it back to speech. I think this will change, right? I think in a few months, not only will we have like on-device capabilities that are, smarter and more capable, but I think also we're going to have multimodalities that are going to allow us to input audio directly into LLMs and get audio directly out of them. But as it stands right now, this is how we do it. So with the backdrop of that, you have a few choices, right? So if you want to do speech to text, you can do on-device, which is what we were talking about earlier. You can use some of the cloud providers. For this demo, we used DeepGram. And so I want to try out what the comments are made in the back earlier, what you're saying about if you end on a number that it doesn't catch that. So we're going to try that out soon. I think that'll be fun. And so when you're choosing one of these, because DeepGram is great, Assembly AI is fine, Whisper is fine. What do you need to consider? Well, you need support for real-time or live transcription. What I mean by that is, like, as you're feeding the chunks of audio in, you're getting the individual words back. And you don't need this for all use cases, but if you want to build something really conversational and that feels live, you do need that. Of course, you want accuracy, and latency and speed is really important. Voice activity detection, as you can see from the painful gaps in the conversation that we just had, is really important. DeepGram can do better, and there's parts of this pipeline that I've optimized and parts that I haven't. But like, how long do we wait before the user has paused, before we realize that they're done, things like that. And then, of course, like streaming protocols and various things. But the second step in that chart that we saw was that after you convert it from speech into text, you need to run it through an LLM. And this in some ways is the most exciting thing, even though like these are all off-the-shelf stuff, right? I mean, it doesn't matter. For this demo, we use like GPT-4o, but you could have easily used Claude or Gemini or what have you. There's a bunch of open source ones, Llama and Mistral, and if you don't want to run it yourself, you can just run it on these providers. But we chose GPT-4o for this. And I think all the interesting stuff happens at this layer, right? Like, I mean, if you want to make it more capable than just being able to answer what is the tallest building in Chicago, or, who won the most recent sporting event, like, let's say you want it to manage your calendar, or you want it to send a text message on your behalf, or you want it to go and like do some research on the internet and find a hotel for you. Like, all of the interesting stuff happens at this layer. But we're going to skip over all of that because I think that is far beyond the scope of what we're really trying to do here. Really, we're just trying to get like audio in and get interesting results out. So, if we kind of gloss over the LLM stuff, the next and final step of this whole thing is just turning the text that comes back out of the LLM back into speech. And so again, like, you can do this on device, Expo Speech, which I've played with, and actually it's the simplest way. It just happens right on device, and it's kind of like on your Mac, if you type at the command line, type say, and then you put a sentence, and it will just like speak it out to you. It's a little robotic. It sounds a little bit like the previous generation of speech synthesis, but it gets the job done. The cloud providers, though, have really interesting things around accents and around being able to sound more lifelike and have more energy and nuance and things like that. So for this demo, we chose Sonic from Cartesia, which is the newest of the bunch, and I think is really powerful for reasons that I'll show you here soon. And I'm going to try to speed through some of this so I can show you more exciting things. Again, things to consider: quality, realism, sure, like, that's important. Latency is probably the most important because this step really can delay everything. And then, of course, you need it to stream back to you. So Whisper from OpenAI, sorry, I'm switching. Whisper was in the previous group, but there are some really good ones in this group that just don't stream. And so you have. You need to stream in order to get low latency, and then everything else is icing on top. Okay, quickly, let's talk about architecture. So you really have three choices. You have device-driven, which is what was talked about in the previous talk, which is where you have your mobile app, it hits your speech-to-text API, and then that comes back, and then it hits your LLM, and then that comes back, and then it hits your text-to-speech. Tried and true, nothing wrong with this. There's some nuance around managing API keys, which we talked about earlier. But ultimately, like, you can absolutely do this, right? There's potentially even some benefits to doing this if, for example, you can do the third piece of this on device, right? Option 2 is server-driven. So this is where the mobile app is just sending audio packets over WebSocket to the server, and then the server is going to talk to DeepGram, Cartesia in our case, talk to the LLM, put it all together, send it back to the mobile app. So this is option 2. Option 3, which I think is really interesting and nobody has talked about yet today, although I have a feeling this is like what the very first demo that was presented earlier is using, is what I call like phone call mode, which is where your mobile app is literally just like a phone receiver. All it does is just send whatever you speak into the mic directly to the server, typically over WebRTC, and then just play back whatever comes in the other direction. So your phone is like a really dumb sort of like speakerphone and microphone in this case. You get some benefits here, which is that like WebRTC already handles a lot of the stuff around like adaptive bit rate and real time, and if packets get dropped and all that interesting stuff. It's built on UDP, which is really fast, but it's also the hardest to build, right? So like this has significant engineering challenges. Of course, there's some libraries that help you out with it, but things to consider: option 1 and 2 are turn-based. I take a turn, the LLM takes a turn. Option 3, you could go either way, right? But you can interrupt and have more kind of responsive conversations. Anyways, for this demo, we chose option 2, which is turn-based, but a lot of the stuff is happening on the server side of things, which is this slide right here. So we're talking over WebSocket to a Node server, and then Node is just calling out to these third-party services. Okay, how it's implemented. We open a WebSocket when the user starts a conversation. The server and the client need to keep certain state. Like the most simplest state is like whose turn is it, but like more advanced state is like what has been said so far in the conversation before I interrupt, things like that. Server live streams that stuff over to DeepGram, which is the one that we chose. DeepGram converts it to text. We then take those tech chunks, we accumulate those, send them to the LLM. After it's accumulated, we have to first use DeepGram's endpointing to detect kind of when the conversation ends and then send it over to the LLM. The LLM will, of course, stream back tokens, and so it's really important at this stage to take those as they come in and send it through the speech pipeline and start speaking. So the questions that we asked the LLM were really short, like, what is the third planet from the sun or whatever, is super short answer. But if I said, tell me a kid's story for my kid's bedtime about dinosaurs, that's going to be a really, really long LLM response, and I can't wait for all of that to finish before I start speaking. So we have to really care about streaming in this case. And I also found that if we accumulate the tokens into sentences and send those sentences over to our text-to-speech, then we get a lot better results than if we send it over word by word or token by token. Okay, I'm going to skip over the prompt stuff. We'll get back to some takeaways here. Actually, you know what? I'll gloss over this, and then we'll get into some more demos. So latency is really key. I think you've picked that up so far. Speech-to-text is much better than it used to be, but is like the most terrible part of this whole pipeline. Like it gets things terribly wrong. It gets, like the LLMs can make up for some of this, but like it really just doesn't understand the context of what I'm saying, because the actual speech-to-text doesn't understand the previous conversation history that we had to understand when we're using proper nouns and things like that. But LLMs are pretty good at compensating for that. Sending chunks or word fragments produces strange results. Like I mentioned, the workaround is to send full sentences. And ultimately, streaming audio in real time with minimal buffering is difficult and very sensitive to network conditions. And so I'll sum that up by saying that real time is very different than streaming in the sense of like I'm streaming a show from Netflix. Because if I'm streaming a show from Netflix, like I can buffer 10, 15, 20 seconds of that so that I'm way less sensitive to network conditions. Whereas like if it's real time, if you're having a conversation, you're much more sensitive to that. So like WebSocket is not necessarily optimal, and if you're building production software, you probably need to either build a ton of tooling around like adaptive bitrate stuff, and network bandwidth kind of like detection over WebSocket, or you'd go to a different technology. But ultimately, this whole thing is a hack. It's a good hack. It's the kind of hack you put together to build, the next generation of really awesome stuff. But on the topic of hacks, I want to show you one last demo that I think will be really exciting. And in order to do so, I'm going to shake my phone and hit reload, and then I'm going to also try to mirror back to my device here. Okay. And then create my volume. Okay, so what we did before is we hit the little start conversation button at the bottom. So this time I'm going to hit vision here. We're going to open a camera. And so I am talking to an audience of React Native developers. And first of all, how do I look? How's this color on me? And second of all, how awesome is my audience? And tell us how good they look. And last thing is that, having a look at this whiteboard, can you tell me what sort of event that we are at? Fingers crossed. Oops, turn my volume on.
Looks attentive and engaged. You are at a React Native meetup event.
Okay, how about my outfit? I'm in front of a lot of people and I want to make sure I look good. So like, tell me about my outfit and roast it a little bit. All right, let's see what comes back. It gets slower and slower as the context has grown.
The purple polo is bold and definitely makes you stand out. The red lanyard is a bit flashy against the purple. A different color lanyard could blend better with your outfit. The overall look is slightly casual for a professional event. Maybe a blazer could add a touch of formality. Your confidence shines through, though.
That was too kind. That was too kind. All right. And what do you think about the audience? All right. I think we've done good there. So I realized that having a conversation with a machine is a lot better with voice than it is with text. But like if you're talking to a human, you can point to something and say like, what do you think of this? Or, what do you think of my outfit? And have a much more rich conversation. And so I think the future of talking to these LLMs is definitely going to include more than just the modality of voice. And so I wanted to build something out, even though it's a little bit of a hack. You can kind of hear it taking snapshots there. So what it's doing is it's taking one snapshot every 1 second. So it's a 1 frame per second video feed, in other words. And then it's sizing it down to 512 by 512 and sending those frames over to GPT-4o. And so that's loosely how that works. The way that I see it is that if we were building like a real-time video feed, like what you saw earlier, the folks that were demoing Tavis at the beginning, if we had a real video feed where we were sending like a live stream of video to the server, and then the server can extract features that are of value, that are important from that video stream, you could imagine a world where we have something like that on our device at all times. Like instead of my parents calling me and asking me like how to plug in their TV and how to set things up, they can literally just show the AI and say, hey, have a look at this. Which one of these is a coax and which one of these is an HDMI cable? And it can walk us through really complex things. And so even though this whole thing is a hack, there's some really incredible things we can do. And everything you saw today was built with React Native. And I added the additional constraint that I did not use a custom dev build, so all of it is built using Expo and Expo Go, so you should be able to clone it down and run it really easily. So with that, that's what I have for you today. I really appreciate you joining, and you can learn more here. Cool. Ask me some questions. What do we got?
I was curious about that phone call mode you mentioned, and I don't know if it's even possible, but do you know any examples of apps that do it using the phone's dialer rather than WebRTC?
So, I mean, you could use like Twilio or something and use the phone's dialer, but I'm going to answer a slightly different question and say that like what you should be doing is using CallKit, which is, at least on iOS, is what's built in, so that way, those like third party, you make a phone call with like WhatsApp and Telegram and stuff, they use CallKit so that it shows up on like your call history and so that you can like background the app and it's still running. All of that is using CallKit, and it gives you the added benefits of like noise cancellation so that if you're on speakerphone, it's not like getting weird feedback. And so you should be using CallKit. So I don't know that it's the phone dialer per se, but like that is the API, the operating system level API you should be using. And it isn't that hard. Like I've built some stuff in React Native that used CallKit before, and it is totally doable. And then the protocol level would be typically WebRTC. Yeah.
I'll add to that. Have you looked into LiveKit?
I don't think so. LiveKit?
Yeah, I think that the ChatGPT app is built with it.
Okay. That's probably worth checking into.
It's essentially a WebRTC framework.
Nice.
And then you can plug in agents on the phone.
That's awesome. Oh yeah, we didn't try if DeepGram is going to let us end in a number. Should we try that? Okay, I got to shake to restart each time here because that's how this goes. Anybody have a question? What should we ask this thing? Oh, I forgot to show you something cool anyway. I totally just did this wrong. What am I doing here? Anyway, ask me more questions while I'm fumbling around here. What do you guys have in mind?
Yep. So in your STT module, you said you want live transcription. Why? Because LLM takes the full question, right, and then generate a response.
So you said text to speech, but you mean in a speech to text?
Yeah, speech to text.
usually just to display what the user's saying, or maybe even just to make it faster. Because remember, latency, like tweaking little things around latency, shaving off. I'll give you an example of like shaving off latency. But like, if you wait till all of the audio is collected and then upload, however many kilobytes of audio, and then wait for it all, it's just going to take longer than if like by the time the last word is finished, 90% of it has already been processed. You just end up with a latency win. I think that's the immediate answer. But I found like even small things, like I'm using DeepGram, and I found that like there's 800 milliseconds sometimes of just opening the WebSocket connection to DeepGram from my node server to their node server or their whatever server. And so I found that even just things, little optimizations like opening up a pool of those connections and then keeping those alive, and then whenever you need to use them, they're already hot and ready. And so like, you can go to great lengths to kind of shave off a little bit of latency, and that's just kind of one aspect of it. Yeah.
Did you truncate the transcript for where you interrupted it on the 7 moons of Jupiter?
Yes. So it'll truncate it both on the transcript that we see, and then it has to be that way on the conversation context history on the LLM side too, because otherwise if I say, hey, what was that last thing you said, it would get it wrong if we didn't do it on both sides, right? Yeah. Okay, let's start a conversation. Hey, so I do have a question, and this time, will you answer me in a really old-fashioned accent? Tell me, what is the number that comes after 71?
Ask your question.
Okay, so I did, but let's ask again. What is the number, and remember, you gotta reply to me in a very old-fashioned voice. What is the number that comes after 71?
Follows 71 is 72.
I got it right. Great. This time, tell me what is the tallest building in Chicago, but tell me in my own voice.
Ooh.
The tallest building in Chicago is the Willis Tower.
Close. That was the last thing I wanted to show you. I did. Thank you. I did have to make a clone of my voice with Cartesia, which is a really awesome tool. If you haven't checked out Cartesia, check it out. You can make, you can mix voices, so I can make a mix of my voice and like a British voice, and you can crank up things like more curiosity or more anger or less, like various different things like that. Cartesia is super awesome. If I had so much more time, I would show you so many more things, but what I would say is go to play.cartesia.ai and check it out. Lots of cool voices here, and like 1920s Radio Man was the one you heard there earlier.
Ladies and gentlemen, gather around the wireless as we delve into a world.
So anyway, lots of great voices to choose from, and because I built on that, I can pull those voices in, and so that's what I've been doing. Anyway, okay, questions? Any other questions? Am I running over?
Yeah, if you're getting started building an app like this, I imagine a lot of the work would be jumping between different LLM providers and seeing which one works best for your use case. But each of them have their own platform, API keys, billing, and probably API as well. How do you make sure that, like, what can you recommend to do, like, to optimize the switching between them, or like experiment A/B testing?
Portkey. There's a thing called Portkey AI, and it just gives you one API, and you just change the drop down and talk to whatever LLM you want.
Okay,
but I think the premise on which that question is based, which is that you spend a lot of time like trying out different LLMs, it's true, but you spend far more time trying out different prompts. And so as soon as you get a prompt perfect for one LLM and you move to another, throw it out the window. So like that's really where you lose your time, right? Yeah.
So coming from a different background, and you might not have like a direct answer for me right now, but I'm wondering how much of the problems that you have when you're building systems like this are more like distributed systems problems, because you have servers running in different places and you have to think about timing of it and like, I don't know, the delay and stuff like that.
I think at global scale that would be true. You'd need everything to happen on the edge as much as possible, so you'd probably leverage a lot of like Cloudflare workers and a lot of kind of like edge compute. But when you're not at that scale yet, I found that most of the problems was just like handling really complex state machines and converting between events coming in to like streams that might get interrupted and errors can occur at different times and propagating the errors up the chain to the correct place. Because you've just got a pipeline of 5 or 6 completely unrelated services, right? Like DeepGram doesn't know anything about Cartesia, doesn't know anything about whatever. And so like, and I'm actively passing packets and chunks of information back and forward, and like then there's like backflow, or what do they call it? Like you need to kind of like whenever something is pushing data out faster than something else can read it in, you got to manage things like that. Luckily, you can skip over error handling because it's just a demo. What can go wrong, right? But that's a good question, yeah. Okay, anything else? I think I'm over time here.
Thank you very much.
Cool, thanks everyone.